So good day students. So today in our session we are going to see about the last architecture in our unit 1 that is Cray T3 architecture. So this comes under RISC architecture. RISC stands for Reduced Instruction Set Computers and it is introduced in the year 1980s. So after a CISC architecture, that is complex instruction set computers, they have introduced reduced instruction set computers. Under reduced instruction set computers, we have already seen about two architectures, that is PowerPC architecture and UltraSPARC architecture. Today we are going to see about the last architecture, that is Cray T3 architecture. So Cray T3E. So Cray T3E architecture is introduced by Cray Research Organization in the year 1995. So Cray contains massively processing system which operates in parallel. So massively parallel processing system. All the systems that comes under Cray T3E architecture are massively parallel processing system, MPP. So mostly the main purpose of Cray T3 architecture is it is used for scientific computing. So in each T3 architecture we are having about 16 to 2048 processing elements, PE, we will call it as PE. So these PEs are arranged in a three-dimensional network. So each PE will contains DEC alpha EV5 RISC microprocessor, then a local memory, then performance accelerating control logic. So each PE will contain all these things. It resides, it's like a small computer. So inside each T3E machines, we are having about 16 to 2048 processing elements. So each processing elements will itself contain a processor, a memory and a control logic. So all these are arranged in a network so that a communication between the processing elements is possible, and also the data is also transformed between these processing elements. Now let us see the different hardware features. So first hardware feature is memory. So our each PE has a local memory. So the capacity of local memory is 64 MB to 2 GB. So this memory is physically distributed and logically shared. So the memory within each processing elements consists of 8-bit bytes. So all are byte addressable. 2 consecutive bytes will form a word and 4 consecutive bytes will form a long word and 8 consecutive bytes will form a quad word, and also we have 64-bit virtual address space. So that's all about the memory. So next hardware feature is registers. So each PE contains 32 general purpose registers, GPR02, GPR31. So, our register GPR31 always contains the value 0. So, it is these 32 general purpose registers are used to store and manipulate integer data and address. So, each register is of 32 bit long. And also we are having 32 floating point registers F0 to F31. So, F31 will always contain the value 0, floating point numbers. So, these floating point registers are also 32 bits. So, along with these 32 general purpose registers, 32 floating point registers, we also have a program counter register which is of 64 bits. So, program counter register will store the next instruction to be executed. Then we also have status and control registers. So, our next hardware feature is data formats. So, in data formats, integers are stored as long word or quad word. Then for storing negative values, 2's complement method is used. Two different types of floating point data formats are there. So, one for compatibility with VAX architecture, the other consists of 4 IEEE standard formats which are compatible with modern systems. Then characters. So, characters are stored in 8-bit ASCII codes, that is 1 byte ASCII codes. Since there are no byte load or store instructions, characters that are to be manipulated separately are usually stored in one long word. So, that is all about the data formats. So, the next hardware feature is instruction formats. So, we are having about 5 basic instruction formats. So, all instruction formats are 32 bits long. First 6 bits identify the opcode. So, first 6 bits helps us to identify the opcode. Some instruction will have an additional function field also. Totally there are about 5 instruction formats. All instructions are 32 bits long. So, our next hardware feature is addressing mode. So, we are having immediate addressing mode, register direct addressing mode, PC relative addressing mode, memory addressing mode. So, for PC relative addressing mode, the target address is calculated. We have already seen the formula. So, target address is equal to the content that is stored inside the program counter plus displacement. So, this is of 23 bits signed. And next, register indirect with displacement. Here the target address is calculated by the content that is stored inside the register plus displacement. So, this is of 16 bits and signed. So, the register indirect with displacement mode is used for load and store operations, and also for subroutine jumping instruction. Whereas PC relative addressing mode is used for conditional and unconditional branches. So these are the various addressing modes available in Cray T3 architecture. So next hardware feature is instruction set. So there are about 130 machine instructions and no byte or word load and store instructions are there. So no byte or word load and store operations, and more than 130 machine instructions are there in Cray T3 architecture. So our last hardware feature is I/O, input and output. So Cray T3 architecture performs I/O through multiple ports into one or more I/O channels. So these channels are integrated into the network that interconnects the processing nodes. A system may be configured with up to one I/O channel for 8 processing elements. So for 8 processing elements we are having one I/O channel. So all the 8 processing elements share this I/O channel for performing input and output operations. So all channels, all I/O channels for we have already seen that we are having about 60 to 2048 processing elements. So only for 8 processing elements we are having I/O channel. Likewise we are having many different kinds of I/O channels. So all these I/O channels are accessible and controllable from all processing elements. So that's all about input and output architecture. So we have seen about all the hardware features. So that's all about Cray T3 architecture. So in our unit 1 we have seen about 6 different architectures. SIC architecture is the basic architecture. Then SIC XC is the next upward compatible model. Then under CISC architecture we have seen about 2 architectures, VAX architecture and Pentium Pro architecture. Then RISC reduced instruction set computers we have seen about 3 architectures, PowerPC architecture, Cray T3 architecture and UltraSPARC architecture. So that's all in unit 1. So in our next class we will discuss about the unit 2. So unit 2 is completely about assemblers.